Hello students, welcome to my channel Agri Training Online. Let us solve another problem from GATE 2016, question number 37. The question says, in a subsurface drainage system, the peak discharge through tile drain under full flow condition is given by Q is equal to 6.715 into 10 to the minus 4 s to the power 0.5 n to the power minus 1, where actually Q is the discharge in cubic meter per second, S is the drain bed slope, and N is the Mannings roughness coefficient. Size of the drain in millimeter is dash. It's a very simple problem where actually the Mannings equation you have to use and you have to equate both them, and you can find out the size of the drain. It is a tile drain in diameter, or you can say diameter. So let us quickly go to the solution part. So first of all, if you see the solution, so here actually the it is not given to find out the spacing between the tile drain. So actually generally one tile pipe to another pipe, there is already the distance it is. It's not required in this case, but here actually the equation is given as Q, or discharge is given as Q is equal to 6.715 into 10 to the power minus 4 s to the power 0.5 and n to the power minus 1. So basically this equation is given, and discharge is given here actually in this case, that is not given actually. So what according to Mannings equation, so Q is equal to, we know there is A r to the power 2 by 3 s to the power 0.5 into the minus 1. So this is the equation actual equation by the Mannings. So in this case, what is A? A is the cross-sectional area. Cross-sectional area. In this case, this is the pipe. So pipe cross-sectional area like this. So that is the diameter is D. So actually you have to find out the diameter, or you can say this is the diameter D. Okay. So now, and R is the hydraulic radius. Hydraulic radius. What is hydraulic radius? In this case, the cross-sectional area divided by, if this is the cross-sectional area, divided by the weighted perimeter. In this case, since the pipe is flowing flow, so it is given pipe is flowing or flowing full. So full means inside all the area is weighted. So this means these are weighted. So if D is the diameter of the pipe, so the perimeter will be pi D. Pi D is the perimeter, and the cross-sectional area will be pi D square by 4. So this is very simple, because everywhere water is there. So therefore the area is this much and perimeter is pi D. We can say P is the weighted perimeter. So therefore the radius R will be equal to, there is A cross-section area divided by weighted perimeter. So in this case, there is pi D square by 4 divided by pi D. Therefore that is R will be equal to D by 2. Sorry, D by 4. The weighted perimeter is, the weighted hydraulic radius is D by 4. So now Q, if you see this equation, that is 1, and this equation is 2. Both equations are same. So putting this value, that is A r to the power 2 by 3 s 0.5 n minus 1 is equal to 6.715 into 10 to the power minus 4 s 0.5 n minus 1. So cancelling these two, we can get A r to the power 2 by 3, that is equal to 6.715 into 10 to the power minus 4. Now putting A as pi by 4 d square. So A is pi by 4 d square, and R is d by 4. So this is d by 4 to the power 2 by 3 there should be equal to 6.715 into 10 to the power minus 4. So now the solving this, or you can say d to the power 8 by 3, there should be equal to 6.715 into 10 to the power minus 4 into 10.08 divided by 5. So therefore, we can get d as we can get the d value. D will be equal to around 0.1 meter, which is equivalent to 100 millimeter. So this is the answer for this question. So the size of the pipe or tile, that is, we can say pipe, we can say the diameter of the pipe will be equal to 100 millimeter. So this is the answer. So this is the answer for this question. So this is very simple answer. So hope you understand. So please like and subscribe to my channel Online.